Okay, so here's your video solutions for your trigonometry worksheet that you can use if you're having any struggle with any of these problems. So we have our solving first, so I'm going to try to get all that in one video, 15-minute video here. So initially, taking a look at a problem like this, what you need to do is recognize you have a quadratic. You can do a u substitution, 2u squared minus 3u minus 2 equal to 0 and turn it into more of an algebra problem. But at our level, we kind of want to say, hey, I recognize that's quadratic. I should be able to factor it and leave the trig functions in. You know that you need a sine x and a 2 sine x to get this first term. Your only choices for 2 is 1 and 2, and I need a minus 3, so I'm going to put the 2 here so that I get 4 sine x and the 1 there. I want to be minus 3, so I want the 4 to be negative, that to be positive. Put your 0, check your signs, make sure everything works out. Now, solving from here, zero product property is 2 sine x plus 1 equals 0, or sine x minus 2 equals 0. You can go kind of straight from, this is part of the arithmetic, is not necessary to be shown when you're doing a lot of your solving. You can go from here and just go straight into sine of x equals negative 1/2, or sine of x equals 2, if you would like, because you don't need to do kind of this step as long as you get it. Just don't make any careless negative mistakes as you're doing it. Now, this one over here, let's talk about this. This is saying find all the x's for which the sine ratio is 2. Now, if you think about your sine ratios, you'll remember that their range is -1 to 1. So 2 is not a valid ratio. And if it's not a valid ratio, then there are no x values for which you get a sine ratio of 2. So this portion has no solutions. So we kind of go, oh yeah, we have to recognize that that doesn't really contribute any solutions to it. Now, this one that we're mainly concerned with coming back over here is this one. And again, you're doing the what quadrant? Sine is the y coordinate on the unit circle. It's negative, so we have to consider quadrants 3 and quadrants 4 for our angles. We have to know what family we're in. The sine ratio is 1/2 for the pi over 6 family, and we're going to use the pi plus the reference angle and 2 pi minus the reference angle formulas to come up with our solutions. So x is going to equal pi plus my pi over 6 reference angle is going to be 7 pi over 6, and then 2 pi minus the reference angle is going to give me 11 pi over 6. And we are looking for solutions between 0 and 2 pi. So our final answer for our solutions is going to be 7 pi over 6 and 11 pi over 6. Now, taking a look at number 2, this looks like a very similar problem, but the problem you have in this one is that you have a trig function of sine and a trig function of cosine. So we first are going to have to fix that we have two different trig functions, and the way to fix that is we're going to use the Pythagorean identity. Sine squared x is equal to 1 minus cosine squared x. So we're going to plug that in right here. So 1 minus cosine squared x minus cosine x minus 1 equals 0. We're going to do a little bit of algebra and combine like terms. We're going to put it in order. I like to put the quadratic first. So this would be minus 2 cosine squared x. Then the linear term, minus cosine of x. And then you've got and remember you're distributing. So you've got a 2 minus a 1. So that's plus 1 equal to 0. And I pretty much always, whenever you have a negative on the squared term, go ahead and multiply through by -1 so that that will change all of the signs. So just to make sure I have a thorough key here, I'm taking my inequality and multiplying it by -1. And then I can turn it into basically the same factoring problem. We very quickly, usually they have fairly easy factoring when you see these, 1 and 1, and I need to have a positive middle term, so I'm going to make the 2 positive negative. And again, I'm going to go straight to cosine of x equals 1/2, cosine of x equals -1, and we'll go ahead and family. Cosine, the x coordinate, is positive in quadrants 1 and 4. This is the pi over 3 family, so we're going to use the reference angle as one of my solutions because that's in quadrant 1. And then in quadrant 2, again, 2 pi minus your reference angle is going to give me 5 pi over 3. From over here, anytime sine and cosine is 0, 1, -1, you know your quadrantal. It's the cosine is the x-coordinate on the unit circle, and where the x-coordinate is -1 is over here for an angle of pi. So we have our 3 solutions for question number 2. All right, let's take a look at question number 3. Now our problem here is we have the same trig function. Over here we had 2 different trig functions, but our problem is that we have a double angle and a single angle, and they have to match. So anytime you see that, you know that you're going to be using a trig identity. This one we're going to use a double angle. Now you have to know your double angle. Your sine of 2x is your 2 sine x cosine of x. So we want to go ahead and we want to substitute that in for the sine of 2x. 2 sine x cosine x equals sine x. Now what we do want to do is we want to not kind of fall into the temptation that you want to divide out the sine of x. The reason for this is because it's a variable and you are introducing a restriction that says I'm dividing out sine of x, which means sine of x cannot equal 0. So you're introducing a restriction that is not a restriction. Whenever you have that temptation, you need to resist it. What you need to do instead is get 0 on one side. And then when you get 0 on one side, then that thing that you are going to divide by is a GCF, and you should factor it out. So now we have 2 cosine of x minus 1, and then in that we would have 2 factors set equal to 0. Again, I'm going to go ahead and solve. And so the solutions from this, and remember this is quadrantal, and sine of x is equal to 0. That's your y coordinate, and that's, I'm going to use this one over here, is at 0 and pi. So x equal to 0 and pi, you would have lost these solutions if you had divided by sine of x. You want to be very careful and not do that. Over here, I already solved that. So cosine of x equals 1/2 is pi over 3 and 5 pi over 3. So we already discussed that on the previous problem. So there are our 4 solutions for this one. All right, let's take a look at number 4. Let's put it way up here. All right, so again, same problem I had before. Notice I have a double angle and a single angle. I have the same trig function, but I do have the double angle. Now, with this double angle, you need to remember there are 3 versions of the double angle for cosine. Now, if this had been a sine, I would use the one with sine. If this one had been kind of a mix of sine and cosine, I might go ahead and try the one that has cosine squared minus sine squared, because that may help me with factoring. But because this is cosine, I'm going to use the identity cosine of 2x is 2 cosine squared x minus 1. So I'm going to substitute that in, 2 cosine squared x minus 1 equals cosine of x. I'm going to get 0 on one side. I'm going to factor, so 2 cosine x. And again, hopefully you are at a level where factoring comes fairly quickly as we're going. We need a minus this time, so minus plus. You should be able to factor it that quickly. You want to be able to be accurate and fast on your factoring skills. Here, cosine of x equals -1/2. Cosine of x equals 1. All right, now here, the negative, be careful, we need negative cosine. So now we're over here in quadrants 2 and 3. Same family as before, pi over 3 family. So we're going to do pi minus pi over 3, 2 pi over 3, pi plus pi over 3, which is 4 pi over 3. And then our quadrantal over here would be this one. And you're tempted to say 2 pi, but remember, if you look at our instructions, it is equals on the 0, not equals on the 2 pi, so 0 is going to be the solution that I'm looking for that one. All right, let's take a look over here at the next one. All right, now this one, you're like, hey, I don't have a triple angle for cosine. But now notice on this one, I don't need, when I'm looking at this, I do not need an identity for this. It's not a cosine 2x, cosine x. I don't have two functions, two cosine functions with different angles. I only have one. So when you have something like this, just one trig function, what you need to do is just isolate that trig function. So I'm going to take the minus square root of 3 over, and I'm going to divide by the 2. So I isolate the trig function to see the ratio. So our ratio that we're looking at is this negative square root of 3 over 2. I ignore the fact that I have 3x. I go to the unit circle, and this is the angle. The cosine of what angles give you this ratio? So this is going to be your x coordinate. It's going to be the pi over 6 family. I need negative for cosine, so I'm in this quadrant. So I'm going to be doing pi minus pi over 6. So let's see, 3x equals, notice I just bring the angle down. So the angle is going to be pi minus pi over 6, 5 pi over 6. Now you have to, when you're doing this problem, put your plus 2 pi k. You have to start with your all and solve to get your between 0 and 2 pi, because this is going to be a transformation. This is where you have shrunk the graph so that it is a third of what it used to be. But that means that it repeats 3 times in the same 0 to 2 pi interval. So where before I would have had 2 answers, now I'm going to have 6 answers because it repeats 3 times as much. And so you have to put this in so that you see that. And then the alternative, I'll just put it down here below, your 3x is going to be, this quadrant is pi plus your reference angle, pi plus pi over 6, 7 pi over 6, plus 2 pi k. And then you divide by your 3. This is going to be 5 pi over 18 plus 2 pi k over 3. And this is going to be x equals 7 pi over 18 plus 2 pi k over 3. And so now we just need to kind of convert and find all the x values between 0 and 2 pi. Now you might want to take your 0 to 2 pi and think of that as 0 to something with a denominator of 18, right? So 2 times 18 would be 36 pi, so we know what we're common denominator. I also sometimes take this and I go ahead and convert it. This would have to be times 6 and times 6. So you're really looking at, for that, when you're adding it in, this is 12 pi k over 18. So you have a common denominator. So if k is 0, you're going to have your 5 pi over 18 and your 7 pi over 18. So that's k equal to 0. Then I let k equal to 1, so that means I add 12 to 5. So that's going to put me at 17 pi over 18. And again, down here, this is 12 pi k over 18. So to add 12 to that, so that would give me 19 pi over 18. And then you're going to do k equal to 2. So you're going to add 24 to 5. So that's going to be 29 pi over 18. And add your 24 to 7, which is going to give you 31. I'm going to squeeze it in right here, right above, 31 pi over 18. And then if you try to go one more, k equals 0, k equals 1, k equals 2, if I try to do k equals 3, I'm outside the window, and of course that would be too big. So we have the 6 answers as expected because it repeats 3 times in the same window that we had. All right, I'm going to stop this video here and we'll go to the next section.